Hey everyone, and welcome. Have you ever thought that you might already be a programmer and you just don't know it yet? Well, today we're going to crack open a Sri Lankan school textbook to let you in on a little secret. The fundamental logic of computer code, it's already a huge part of your daily life.
So let's start with a question that sounds kind of like a riddle, right? What on earth does making a cup of tea have to do with writing lines of code? The connection, believe it or not, is beautifully simple. Both of them, at their core, depend on a clear step-by-step plan to turn some kind of raw material, whether it's tea leaves or raw data, into a finished product.
Just take a look here. On one side, you've got a simple maze, a series of choices. On the other, a screen full of computer code. Now, they look worlds apart, I get it. But really, at their heart, they are doing the exact same thing. They are all about following a logical path and making specific decisions to get to a specific result.
So what is this secret logic that we all seem to know? Well, it turns out that for just about any problem you can think of, we instinctively use a really simple three-step model.
Okay, step one is the input. The easiest way to think about this is like the ingredients for a recipe, right? If you want to bake a cake, your inputs are the flour, the sugar, the eggs, all the raw stuff you need to even get started.
Then, of course, you've got the process. This is the recipe itself. It's the set of instructions, the step-by-step actions you take to mix all those inputs together in just the right way.
And what do you get at the end? The output. Your delicious, perfectly baked cake. It's the final result. The problem you had, which was, not having a cake, is now solved.
And the textbook gives us this great down-to-earth example, posting a letter. So your inputs, the paper, pen, and an envelope. The process, that's the writing, the folding, putting it in the envelope, and sticking on a stamp. And the output, a letter that's ready to be sent. It's such a simple way to see how we break down literally any task.
Okay, so that process step we just talked about, the recipe part, it actually has a fancy name in the world of computing and technology. And I'm pretty sure it's a word you've heard thrown around a lot. It's called an algorithm. And really, an algorithm is just that, a step-by-step procedure for solving a problem. It's the reliable, detailed plan that acts like a bridge, taking you from your starting input all the way to your final output.
I mean, the textbook puts it perfectly. An algorithm is all about having a plan. It's basically the difference between just wandering around hoping to find something and actually having a map that leads you straight to your destination.
But this brings up a really interesting question. When you're trying to solve something, is there only one single correct way to do it?
The answer is absolutely not. I mean, think about your daily commute. If your usual road is blocked, what do? You find another route, right? Well, programming is exactly the same. There are often tons of different algorithms, different paths that will get you to the same exact result. And this is where problem solving gets really creative. This example from the book is just brilliant for showing this. How do you find a rectangle's perimeter? Well, all three of these options will get you the right answer, but a good programmer is always thinking about efficiency. See that third option? It takes fewer steps. In the software world, that can be the difference between an app that feels super fast and responsive and one that's slow and just plain frustrating to use. So this whole collection of all the possible right answers is called the solution space. And a huge part of being a good programmer isn't just about finding a solution. It's about looking at the entire solution space and picking the best one for that specific situation. So if we're going to build these algorithms, what are our tools? Well, it turns out that every single complex set of instructions you can imagine, no matter how wild, is built from just 3 basic logical moves. No, seriously, I'm talking about everything from making a simple cup of tea to programming a satellite to orbit the Earth. It's all built from the same 3 fundamental pieces. If you can get your head around these 3 moves, you've basically mastered the universal grammar of programming. First up, the most straightforward one, sequence. This is just doing things in order. Simple as that. You have to put your socks on before you put on your shoes. It just doesn't work the other way around. In coding, just like in life, some steps just have to happen in a specific, unchangeable sequence. The second move is selection. This is your decision-making tool. Think of it like a fork in the road. You get to a point where you have to ask a yes or no question, and your answer determines which path you're going to take next. And this right here is a perfect way to visualize it. The question is dead simple. Is the test score 35 or higher? If the answer is yes, you flip the switch to pass. If it's no, you flip it to fail. That is selection in a nutshell, a clear choice that's based on one specific condition. And our third and final move is repetition.
You'll often hear programmers call this a loop. This is when you do something over and over and over again until a specific condition tells you it's time to stop.
Just think about a teacher taking attendance in class. They call the first name, mark it, call the next name, mark it, and they repeat that same exact process for every single student until they get to the last name on the list. That everyday task, that's a perfect real-world example of a loop.
All right, let's tie this all together. We've looked at the input-process-output model, we've defined what an algorithm is, and we've uncovered those 3 core building blocks: sequence, selection, and repetition. So what does this all mean? How does this connect making tea to, building the modern world?
Okay, this slide right here, this is the big reveal. On the right, you've got these official-sounding competencies from an advanced information and communication technology course. But just look at the left column. Uses problem-solving process? That's just a fancy way of saying understanding the problem. Uses algorithmic approach? That's just creating a plan, an algorithm. And uses control structures? Well, that's the formal name for our 3 moves: sequence, selection, and repetition. The language might sound more complicated, but the logic? It's exactly the same. You already know how to do this.
So, the same fundamental logic that helps you follow a recipe is the very same logic that builds the apps on your phone, that runs the internet, that powers our entire digital world. You are, by nature, a logical thinker. You already have the tools. So the only real question left is, now that you can see the code hidden in everything around you, what problem are you going to solve first?